Okay, I'm recording for Harrison, Remington, Talon, Cole, and that's it, right? I am recording now. Those couple of them are taking a quiz. So Cole, if you're wondering, they're not all missing. They're just taking a quiz that they have to make up. So anyway, all right. So Algebra 1, here we go. Chapter 3 review. This kind of, I think, goes in order. There were 6 sections to this chapter. And one of the first things we talked about was relations and representing them as a table, a graph, a mapping, and then listing domain and range. So these are ordered pairs. We're going to first do a table. Okay, how do we do a table?
You make a table.
X and Y,
You make a table.
and we make a table. And we have four points to do a table, so -3, -3, -1, 0, 4, 0, -1, -2. Yeah? Was that okay?
Yeah.
Is that too fast? All right, so they want let's do a mapping next. Mapping. How do you do a mapping? Yeah, you call them the domain, and you call them the range. And then we do like little bubbles and we draw arrows, right? Whoa, that was kind of a little crazy on my bubbles. -3, what's the next one you do?
-1.
-1, 4, and I also have another -1, so I'm not going to put it twice. Can I do that? My range, I've got -3, 0, and -2. Oh yeah, this is not a function. How do you know that?
Because the x's repeat.
The x's repeat. Okay, so if I do my first point, -3, -3, that's this guy right here. Okay, -1 goes to 0. 4 also goes to 0, but that's okay, right? 4 can go to 0. That if that was it, then this would be a function. But the fact that that last coordinate, -1, -2, that's what makes it bad, right? You cannot have two x's going to the same the same x going to two different y's. Blah 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 blah. Then graph, and then we got to list the domain and the range. That was a lot of stuff on one problem. Holy moly. Okay, -3, -3. There's that one. -1, 0. There's that one. 4, 0. Do you guys know what you're doing? Are we doing okay? -1, -2. There's that one, and he looks like that. Okay? Something of that nature. Okay? Now, looking at this graph, how do I know by looking at this graph that he does not a function? If I do the vertical line test, whoop, he's going to fail right there. You see that? He's going to touch 2 places. So that's by looking at the graph how I know he's going to fail. All right, domain. You remember we use these little curly Q brackets, right? And we list out all the numbers. And we try to go in order. So what's your smallest number for your domain? -3, and then what? -1, and then 4, and is that it?
Yeah.
You betcha. Okay. Then the range, we go in order, I think, too. Do we go in order? What's your smallest range number? -3, and then? -2, and then? 0, is that it?
Yeah.
You betcha. You need a calculator. Okay. How about that? Do we answer all of the parts to the question?
Your phone here.
There's that. Okay.
So it's in his pocket.
Harrison doesn't have a phone. He got it taken. He wasn't being good boy.
Okay. All right. Good. Number 1.
Pocket right now.
Number 2. Identify the independent and the dependent. Which one is X and which one is Y? Which one is independent, X or Y? X is independent. The Y depends on what the X is. Okay, but they want us to figure out what is what. So the independent or the X is the, I heard Ethan say it, hours, right? That's the x-axis, right? The Y or the dependent variable is the distance, right? The distance depends on how long I have been traveling. So distance is dependent. The independent is the hours. Good? Describe what happens in the graph. What's happening?
So decreases, then stops and decreases.
Okay.
As the distance goes down, the hours go up.
Yep, as the distance goes down, the hours goes up. So he is he biking? What are we doing? We don't know what we're doing. Okay, so he's traveling.
So he's
Then-
traveling, then he takes a break.
Then he takes a break. That's where that horizontal line is. So the distance is not changing, but the hours is changing, right? Traveling, then break, then traveling again. You could say traveling again until Until home, yep. Okay, because it does level off at 0. So he's traveling again until he gets home. Yep. Okay, happy with that? Something of that nature. It doesn't have to be exactly like that, but as long as you're telling kind of that story, right? Okay. All right, number 3. We have a data table, like a X and Y. Which one is X, by the way? The top one, the Y is the bottom. That's usually how your table is set up. The data in the table shows the GPA of some students given the number of hours that the students spend playing video games. Oh, this is so funny. They're trying to show a relationship and say that video games are bad for you and that your GPA is negatively affected by your video games. Is it? Are my big gamers the ones with the lowest? And my not so much gamers are the ones with the highest? According to this, it says yes, right? I don't know. You're the one with the 3.75 right here, because you only game for 2 hours. It's less than 2 hours. 2 hours a week? Okay. What games do we play? Fortnite. That's what we play. Isn't that like a shooting game? Whatever. Graph the data from the table. That's all we're trying to graph, right? This is going to look somewhat linear, but not completely, right? Because we have 2 that are at 3, right? Okay, but that's okay. We want time, and we want that to be our x-axis. So I'm going to go time in hours, and I'm going to go over here. This is going to be GPA, right? GPA. Okay, let's figure out how we're going to label our axis, okay? So I'm going to go from 0 all the way to how much time? 16. Okay, half of that would be like right here at 8. Half of that would be right here at 4. Half of that would be right there at 12, right? Then we've got 2, 6, 10, 14. And then we could do like the little tick marks in there for each one, right? I'm not going to label all of them, but I have tick marks for each one.
Can we make the axis on that little, like, the little squiggly thing that starts at like 2?
Yeah, we could. We don't necessarily probably have to, though, if we just go to 4. Yeah, we wouldn't. I mean, you could, but we wouldn't necessarily have to. There's 1 and there's 3, right? 1, 3, I don't know. There's the halves. I don't know. I'm just going to leave it. You could do the little squiggly mark. That's fine. Okay. All right. Graphing 16 was at 2.75, so about there. This is hard for me to see because I don't have a straight edge. If I were you and you wanted to make it like exact, I would take another piece of paper and like, use it as like a straight edge. You think I should?
Yeah.
Okay, I will try. 14 is at 3. Exactly. So 14 right here is at 3. I don't know. 11, though, is also at 3. So we have 2 that are right there. Okay. But does that make it not a function? No, he's still a function. The y's can repeat, but the x's can't. Okay, so 8 then is at 3.25. So about there. Then we have 3.5. 4 is at 3.5. Oh, yes. Wrong. He should be all the way up here. You're right. I lied. That should be gone. Yes, thank you for fixing that. 2 is at 3.75 right there. Okay. So he looks kind of linear almost. Okay? Now, if you would have put a break in there, you know what would happen? Like your dots would be like this. Like there would be more of a slant, which is totally fine. Okay? But there's that. Okay? Good? That works. Okay? Determine whether each relation is a function. This is just a yes or a no, right? Number 4, is that a yes or a no?
No.
Nope. These 2 screw it up and these 2 screw it up. So not a function. Or you can just put no. Okay? Number 5, what do we use to judge that?
Vertical line.
The vertical line test. Will it touch more than once?
Yeah, it's x squared.
He's going to be a function. Yes. He's a function.
Is this one x equals, or y equals x?
This is y equals x squared. You betcha. Yep. You guys will be way ahead of the game when you get to Algebra 2. That's awesome. Now, number 6 is kind of tricky because why not? If you're looking at these 2 little points, they snuck that one little point in there, so not a function. Or you can just say no. I abbreviate function as FCN. Like, give us a bunch of those, right?
Abbreviate that as no.
What?
I abbreviate not a function
As no. Okay, sure. Okay, now we've got to figure this one out. Determine whether each relation is a function. Number 7.
Yes.
what if I were to graph number 7, what would it look like?
It would start at 6 and it would go.
Yeah, it is what kind of function? What kind of function is it though?
It's a linear.
It's a linear function, right? It's x and y to the first power, right? So if I were to graph him, I would start at, you said 6?
Start at 6 and then go back to.
And then you go down 2 over 1, down 2 over 1, down 2 over 1, like this, right? Some sort of a linear function that looks like that. I don't know. But our whole purpose was determine whether that's a function or not a function.
Y equals mx plus b form or slope form.
Yeah, so he will be a yes, right? We actually didn't even have to graph that because if we know it's a linear function, we know it's going to pass the vertical line test, right? Okay. So he's going to be okay. Number 7. Now number 8. Let's figure out what he looks like. X equals -2. We go to -2 on the x-axis, and he is straight up and down like this. Will he pass the vertical line test?
No.
Not a function. Not a function. Okay? Do we see why? That's what he looks like? Okay, now this one, we could graph these if we want to, but we're really just looking at, do the x's repeat?
No, we're good.
Nope. So yes, he is a function. Okay, something of that nature. Like give us a bunch of those, right? Those are the easy ones we want free points on.
Yes.
Okay, now they have 2 functions, and this is in function notation. So they have f of x equals 2x minus 1. That's a linear function. G of x is x squared plus 5. That's going to be a parabola. We don't care. We don't have to graph them. We just have to do what on 10?
Solve.
Solve by
Plugging it in.
plugging -9 in where?
For x.
For x on g, right? So I'm plugging -9 in there, and that's -9 squared plus 5. Yeah, yeah? If I do -9 squared, is that positive 81 or negative 81?
Positive.
Positive, because you're squaring the negative, right? Negative times a negative makes a positive. So that's 81 plus 5, and that is 86. Boom. Okay?
And the next one's 15.
The next one has the plus 10 on the end of it. So let's just save the plus 10 for a minute. We need to do f of 3, okay? So I'm going to plug 3 into f. So 2 times 3 minus 1, right? 2 times 3 is 6, and 6 minus 1 is 5, right? So that means that f of 3, this guy right here, was 5. So final answer? 15, right? We have to do the plus 10 after we figure out the f of 3, right? Okay? All right, you do number 12 real quick, and then we'll get an answer. So you do number 12. You do number 12. You do number 12.
Yeah. French bread? You do you. I'm not too fond of it.
Okay, check yours with mine when you're done.
Oh yeah.
Brexton got it? Or is he cheating?
Well, maybe Lane yelled it really loud.
Okay, but do you know how to do it?
He lives in Mars or something like that. Well, Mr. Messi said.
Yeah.
Is positive 9 plus 5 is 14 minus 20 is negative 6.
Yep.
You know what you're doing?
Yep.
Yeah, yeah? Okay, that was number 12. Yes, yes? Okay, number 13 is talking about the volume of a cube. Did you know that the volume of a cube is taking all 3 sides times each other, right? So here's what a cube looks like. Whoop. And a cube has all of the sides that are exactly the same. So volume of a rectangular prism is length times width times height, right? Length, width, height, if I multiply all those together. But if all of those are the same and they're all labeled with x, it's x times x times x, or x to the 3rd power. Do you see how they got that? They want to know what f of 4 is. So if I do f of 4, I'm plugging 4 in for x. 4 to the 3rd power is?
64.
64. Did you know that?
Yeah, I did.
You did?
Yeah,
4 to the 3rd power, 64. Okay. 64 is the, do they have units? They don't have a unit. But 64 is the volume. Find and interpret. This is the volume of a cube with sides equal to 4. Okay, that is the interpret part. Don't forget to do that, okay? Every time you answer a question, I would strongly encourage you to go back through and read the question over again so you don't miss a part, right? Sometimes these will have multiple answers, okay? So 64, yes, that's the answer, but what does that tell you? That's the interpret part. The volume of a cube if the sides are 4. Got it? Yeah, yeah? Okay. Perfect. Just put them in my tray. And we are on number 14 on the review. Make it. All right. Okay. So there's a lot of questions being asked on 14. Starting with 14, they ask for the x and the y intercepts. And then they also say positive and negative. Okay, I graded you guys' papers the other day, and some people do not know what positive and negative. I'm going to pick on that corner over there. He's not even listening.
Me?
Yeah, that corner over there doesn't know what positive and negative are, so make sure you listen. The x-intercept, the y-intercept, then we need to know what positive is, and we need to know what negative is. Okay, so here we go. X-intercepts is where it crosses the x-axis. How many places does it cross the x-axis? 2, and they are right here, and that is at -2 and 4. Those are my x-intercepts, okay? Now the y-intercept is where it crosses the y, and that is right here at 2. Okay, now we got to talk positive, negative. Positive means what? Above water. Where does the water live? Right here. This is the water, okay? So he is positive right here in this purple region, right? And they usually say between something and something, right? So if you want to go ahead and do that, you can say between what and what? Between -2 and 4, right? -2 is right here, 4 is right here.
Less than x, which is less than 4.
Yep, or you could say -2 is less than x, which is less than 4. That's another way of writing that. That's how you'll see it, like in Algebra 2 and in Geometry and in Trig. You'll see it written like this instead. But if you're not quite there, that's fine. Okay, you can say between -2 and 4. Now, I have 2 places where he's below water. I have this guy, okay? What's this guy labeled as? When x is less than -2, right? He's on this side of -2, okay? That's less than. Or when he is on this side of 4, so when x is greater than 4, he is also below water. Does that make sense? Okay, if it doesn't, you let me know, and we can help you. Okay. 15, do you want to try 15 on your own?
No.
Or not? Yeah, yeah? Okay, let's try it on your own. I will fill it out also. You try, do as much as you can. Ooh, they made this one hard. Okay. Figure out where that cutoff mark is, where it switches from positive to negative. Whose phone is this? Do we know?
It's like Harrison.
It's Dennis.
Who's
I bet he left it in change for a calculator.
Oh, gotcha.
Caleb left his computer.
She probably made him. What math class are they in? Henderson's? Gotcha. Okay. Did we get that for 15?
For 16 by ourselves too.
16 by yourself too? Okay, go ahead.
Oh.
You're fine. Just try it. I'm going to give you the answer. Okay, so try it on your own. You'll never know if you know how to do it if you don't try it on your own, right? Okay. Okay. You getting this? Good, good, good. Very good. Very good. Okay. How are we feeling? That's what I got for 16. Check your answer with mine. Did you get it? Yeah, see, look, you can do it. You just need to have confidence, Brexton. I helped coach 5th and 6th grade volleyball, and the last couple practices we've had Braxton Court running around the gym with us or whatever, because his mom helps coach also, so he was at the last couple practices, and I cannot tell you how many times I called him Brexton. And everybody's like, it's Braxton. I'm like, I'm ruined. I'm ruined. You ruined me for every Braxton, because I call everybody Braxton, I guess, or something. I don't know. You did? Yeah? Yeah? In fact, I know more Braxtons than I do Brextons, but I've never had any of them as students. So now that I have you as a student, everybody's Brexton and not Braxton. I don't know.
I know one Braxton.
You know a Brexton?
Yeah.
Yeah?
He's one of Broderick's baseball teammates.
Oh, nice. Cool. Cool.
No.
There's a Brexton. He said he only knows one other Brexton. I know 2 Braxtons, I think. One of them is, well, both of them I think are in Layla's class. Braxton Peter and Braxton Court. They're both in Layla's class. So there's 2.
There used to be a
2
Braxton.
Oh, yeah. No, I never had him as a student. How old is he?
He's in our class.
Oh, he's in your class, Braxton Stinkin'?
He was a great student.
No, he was not.
We were, if it was opposite day,
Yeah, he's an A+ student.
I don't know. I never met him.
He was a Ramsey class. Because he was in there running with us. He's hit before.
Okay. Are we ready for 17?
And other than the one day when he threw his mouthpiece in his dart.
17 is asking for a projectile. We have something that's being launched out of a window, thrown from a window. So the window is 11 feet in the air. So this might be a 2nd-story building. We're launching it up, and then it's going to come down. How long does it take for this thing to reach the ground?
4.5 seconds.
4.5 seconds. Okay, that's important. Use the graph to estimate the x and y intercept. X-intercept, y-intercept. Where the function is positive, where the function is negative. Okay? The x-intercept you said was 4.5. Okay? And it says interpret the meaning. So 4.5 is the amount of time to reach the ground. Okay? What's the y-intercept? Where it touches the y-axis. 11. And what's that tell us?
Where it starts.
Starting what?
Height.
Starting height. Starting height. Okay? It is positive from what to what? Between 0 and, I'm going to say 4.5 because that's where he hits the ground. So between these two, he is positive. Okay? I think the book, and I don't agree with them on this, they say he is negative on all the other places. He's not negative. He's never negative. Okay? I don't know why your book on story problems tells you that it's allowed to be negative. It does say that it's negative past that. What?
It's hitting the ground.
Yeah, I know. So, but the book, like the answer in the book says that, like the answer here would be that it is negative when x is greater than 4.5. No, it's not. If this is a story problem, it is not ever negative. So I don't buy that.
I just wrote up positive the whole time.
Yeah, positive the whole time. Right, that's fine. Okay. All right, next one, 18. Xavier is driving 520 miles from Amarillo, Texas to San Antonio, Texas. Each hour, his distance decreases by 65 miles. The table shows the function relating distance, blah, blah, blah. So at 0, we're talking about the distance that is left to travel. Does that make sense? They should have put distance left to travel. So at a time of 0, we have 520 miles left. At 4 hours, we have 260 miles left. Does that make sense? Okay. All right. Now, they want to know whether this is a linear. No, wrong. They say find the intercepts. Okay. The x-intercept and y-intercept. Okay. Now, real quick. People mess these two up all the time. It's the opposite of what you think. If we're talking about an x-intercept, what should be equal to 0? The y should be equal to 0. It's the opposite of what you think. So which one is the x-intercept? 8, right? 8 is the x-intercept because that's where the y value is 0, yeah? Okay? Now for the y-intercept, the x should be 0. So what is the y-intercept? 520 miles. Yep. Find the intercepts. Describe what the intercepts mean. Okay, so 8 is the what?
How long it takes? How long it takes to go?
The time for the entire trip. Okay, what does 520 represent?
How far to go?
How the distance of the entire trip. Something of that nature. Now, it doesn't have to be exactly that, but something like that will work, okay? I went ahead and just put that all on part A, but B is that green part, okay? B is this. Okay? Happy with that? Questions? Are we doing okay? Does this make sense? Yeah? Okay. We'll do a couple more and then we'll stop. I don't want to get all this done today because tomorrow we'll finish whatever we have left over. I don't know why this only printed single-sided. What a waste of trees. Sorry. Tomorrow we'll finish this and then we'll do a little bit of whiteboard work. How about that? Okay? So, what? I know, I did. A whole tree? I doubt it. Yep. All right, number 19. What should we do?
Start at 2.
They like to write things about me. I don't know.
Start at 2.
I am not. They're trying to be mean to me.
Is
I
that
am
first
not.
one true?
Is the
No.
second one true?
No. The second one is very true, yes. Yes.
Is the first one true?
No, the first one is not true. They're trying to make me sound like I'm a bad person. I don't know.
Having good handwriting, she will diss you.
Oh, because Dylan didn't put his name on his paper the other day, and I was going through trying to figure out whose it was. And I'm like, and I have somebody with no name on its paper, and it's a girl. And Dylan's like, that's my paper. He has very girly handwriting.
Yeah,
I'll show it to you. Here, when we get done, I will show you Dylan's paper, and you tell me that that's not girly handwriting. Dylan Otten, okay? All right, so, yes, I will show it to you. 100%, it looks like a girl's handwriting. And so he was, like, very hurt, yes, when I said it looked like a girl's handwriting.
Do you start at 2
Sorry.
and then you go? I can say about everybody.
Okay, so here's what I want to do. I want to move this 0.5x onto this side, okay? So if I subtract 0.5x and subtract 0.5x, this is what I want to do. What will be left on the left side? 0 equals negative 0.5x equals or plus 2, right? If I make this into a linear function, right? If I make this into a linear function, okay? 0, it takes the place of like y, all right? What is negative 0.5 as a fraction?
Half?
Negative 1/2 x plus 2. Okay, so I'm going to graph this linear function. I'm going to start at 2, right? And 2 is right here, and I'm going to go down 1 over 2, down 1 over 2, or up 1, left 2, right? And he looks like this. Okay, and then I want to find the answer. What's the answer going to be? 4, because that's where it crosses right here, right? Now, also, Anna said, wait a second, if you just take this thing and you solve for x, right, you would divide by 0.5, right? What is 2 divided by 0.5? 4, right? But this visually shows you why that is, right? Whatever.
That works on everyone.
That works on every single one of them.
I was going to say, is there a connection between my mistake and the actual method?
Yeah. It will be that way all the time.
Wait.
Yeah.
Jaw drop.
Yeah, jaw drop.
You want this one to be like no solution?
Number 20, let's see what we do here. So I'm going to try to move all this stuff over to this side. So I'm going to subtract the 3x, right? And if I do that, this is gone, and I have negative 1 equals 1. Okay, let me keep going.
At 2 on y-axis.
I have, if I add 1 to the other side, this is 0 equals 2, or y equals 2, right? Y equals 2 is this line right here. Okay, where will he touch the x-axis?
Never.
He will never touch. Y equals 2 will never touch. Now, if you really want your mind blown, my trig kids right now are doing these, but they're not moving anything. Are you ready? They're not moving anything. They're graphing 3x minus 1. 3x minus 1 is down 1, and it's up 3 over 1, up 3 over 1, down 3, left 1. This is what this first one looks like. Okay? The second one, they're graphing 3x plus 1. So I start at positive 1, and I go up 3 over 1, or down 3, left 1, and this is what this one looks like. Boop, 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 boop. And what I want to do is I want to figure out where those two are equal to each other. Where are they equal? They don't touch because they're parallel. So that's another thing that you could have done was graphed each side and figure out where they're going to touch. Well, they're not going to touch because they're equal to each other, or they're parallel to each other, right? That makes sense? Okay, so that's another thing that you could have done, right? Okay, either way. That was 20. Let's go 21. Camilla is making floral centerpieces for a party. She puts 8 flowers in a vase, and she has 144 flowers, okay? So what they have is their starting function is 144, which is what I'm starting with, and then I am subtracting 8 for each vase that I have, right? C is the number of vases that I have, okay? Describe, let's see, find the 0 of the function. Okay, so if I'm trying to find the 0, what do I do? F equals 144 minus 8C. What do I do to find the 0?
0 equals 1.
Yeah, I'm going to plug 0 in over here for like the Y value, right? Okay, so 0 equals 144 minus 8C. What should we do? Yeah, let's plus 8C over.
What notes can I use? Like,
Whatever you want.
can I just bring my book?
Sure. 8C equals 144, and then let's divide by 8. Okay, 144 divided by 8 is 18.
Oh, I got it for you.
Woo! Now, 18 is my answer, but describe what this value means in the context of the situation. 18 what?
The max number of vases.
18 is the max number, I love it, a max number of centerpieces or vases that we can make. Okay? 18 total. In order to have 0 flowers left, we would have 18 vases. Good, good? Okay, let's do, what do we have? Let's do 2 more. Let's do 22 and 23. Because this is discrete, continuous, or neither. Okay, 22. Is that one discrete, continuous, or neither? Discrete is dots, right? Discrete. Okay?
Neither.
Discrete. 23 is, it would be continuous if all of this was connected, right? But it's not. We have, continuous means connected. So this one is a neither. Like, give us a bunch of those on the test, right?
Yeah.
Let's do that. Yep.
Quiz just on those, or the whole test?
The whole test just on those, right? You'd find a way to still screw that one up, Brexton. Oh, shoot. Okay, we'll start with 24 tomorrow. Okay, we'll do 24 to the end, and then we'll do some whiteboards. Okay?
You're not wasting trees.
That way I'm not wasting trees, sure. Okay, all right, goodbye.